In 1965, a young mathematician published a short paper that changed everything we thought we knew. He proved that dying stars weren't just fading away, they were actually crushing themselves completely out of existence. Years before, in 1939, J. Robert Oppenheimer and his student Hartland Snyder ran the numbers on what happens when a giant star runs out of fuel. Their math showed that without the outward push of nuclear fire, gravity would eventually win, squeezing the star into a single tiny dot of infinite density. But to make that calculation work, they had to imagine a perfect star. They treated it like a smooth, round ball of dust that collapsed in total harmony, with every piece of matter falling toward the center at the exact same time. The problem is that real stars are anything but perfect. They spin at thousands of miles an hour. They are lumpy, chaotic, and bulging with violent storms. Because real stars are so messy, the world's top scientists, including Albert Einstein, assumed this infinite collapse would never happen in the real world. They figured the churning matter would slosh around, miss the exact center, and just bounce back out. This loophole gave everyone an excuse to stop worrying. They decided that those infinite points of density were just a harmless math glitch, a quirk of using overly simple models, rather than a real thing you could find in space. Then came Roger Penrose. He realized that if you want to find the truth, you have to stop looking at the messy sloshing of the star's matter and start looking at the invisible floor the star is sitting on, the actual fabric of space and time. This chart shows how he visualized the universe. Those green arrows on the bottom are the 3 directions we move in space, and that blue arrow pointing up represents the steady march of time. Nothing travels faster than light, limiting how far you can move through space as time advances. This red cone marks that absolute speed limit. Every object is forced to stay inside these red walls. Your path is permanently confined to that expanding volume. But gravity changes the shape of the floor. Near a massive star, space itself bends, physically tilting these cones inward toward the center of the mass. Penrose saw that if you could track how extreme gravity steers these cones, you'd know exactly where every piece of matter is allowed to go, no matter how chaotic the star itself is. Imagine you're riding on the surface of a collapsing star. As you fall inward, the star gets smaller and the gravity gets exponentially stronger, pulling on you with more and more force. You cross a threshold where gravity is so intense, these cones tilt completely over. This is a trapped surface. Every path strictly points toward the center. Even a flashlight pointed directly outward would have its light beam dragged backward into the star. Penrose proved this using a type of math that looks at the core properties of shapes. He showed that once this no-escape region forms, it stays that way. It's like a dent that can't be popped back out. Suddenly, that old loophole about lumpy stars disappeared. It doesn't matter if the star is spinning, dented, or irregular. Once that trapped region exists, the chaotic reality of the star can't save it. Every single path through the future leads to the same inevitable destination. This leads us to a final, mind-bending conclusion. Because every path is being forced toward the center with nowhere left to go, those paths eventually just stop. They reach a dead end in space and time that mathematicians call geodesic incompleteness. This is the moment where our understanding of physics breaks. The paths simply vanish because there is no next second or next inch for them to inhabit. The math of the universe literally runs out of room. Now, this doesn't tell us what a singularity looks like or what it would feel like to be there, but it does prove something massive, that Einstein's own rules of gravity lead directly and unavoidably to this breaking point. Black holes aren't math glitches, they are a mandatory part of our reality. When a young Stephen Hawking read this proof, he had a world-changing realization. If a collapsing star is like a movie of a path reaching a dead end, what happens if you play that movie in reverse? If you flip the math, that dead end becomes a beginning. In our next episode, we'll see how this same logic helped us understand the greatest beginning of all, the Big Bang. Last time, we explored how Roger Penrose proved that the singularity at the heart of a black hole is an inescapable reality. Now we need to look at the specific tool he used to prove it. Imagine you are floating in the total silence of deep space. You're far from any planets or stars, and you're holding a single powerful flashbulb. When the bulb pops, the light travels away from you at the same speed in every direction. This creates a perfect sphere of light that steadily expands into the darkness. Because there is no gravity here to interfere, nothing stops these photons. The sphere just keeps growing, moving further out into space for the rest of eternity. This is the baseline rule for normal space. Light expands outward without resistance, always moving forward through time. Now, let's move that experiment inside a massive dying star that is actively collapsing. In general relativity, gravity behaves like the fabric of space moving. Inside this star, that fabric is plummeting inward toward the center, faster than the speed of light. When the flashbulb goes off here, something impossible happens. Even the light rays that are trying to travel outward are caught in that inward rush. They are dragged back toward the center by the sheer movement of space itself. Penrose defined this region as a trapped surface. It's a boundary where the gravity is so extreme that it forces every future path, even the path of a light beam, to turn inward. This diagram from Penrose's own notes shows the geometry at play. In section B, you can see how light emitted from both sides of the surface ends up converging toward the same point, rather than spreading out. By identifying this geometry, Penrose showed that once a trapped surface forms, everything inside is squeezed into a single point. The math leaves no other option. A singularity becomes inevitable. Understanding the math of a trapped surface was one thing, but physicists needed a way to actually visualize it. They needed a way to map the entire life of a black hole on a single page. This is a mapmaker's nightmare. How do you draw a diagram of a universe that is infinitely large and lasts for an infinite amount of time? It's the same problem we face when mapping the Earth. Because the world is a sphere and paper is flat, we have to distort the sizes of the continents to make them fit. We trade accurate sizes for a map we can actually look at. To see a black hole's place in the cosmos, Penrose couldn't use standard graphs. He needed a way to squish infinite space and time together. He called his solution conformal compactification. It's a mathematical trick that compresses infinite distances into a finite box. The artist M.C. Escher used this exact logic in his circle limit prints. As you look toward the outer edge of the circle, the fish gets smaller. That edge represents a distance that is infinitely far away. The crucial rule here is that while sizes change, angles don't. If you look at the eyes of the fish, they remain perfect circles. Their relative geometry stays intact, even as they shrink toward infinity. On a Penrose map, we use this rule to track light. No matter where it is on the page, the path of light is always drawn at exactly a 45-degree angle. By locking light to that specific angle, Penrose created a map that could accurately track cause and effect across the entire history of the universe. This is the basic Penrose diagram. Time flows vertically, moving upward. Space is horizontal, extending left and right. The edges of the diamond aren't walls, they represent infinity. The corners are infinitely far away in space, and the top point is the end of time. Because nothing moves faster than light, any object's path must stay inside these 45-degree lines. This light cone sets the absolute speed limit for everything in the universe. This empty diamond represents the entire history and future of a universe, bounded perfectly by the laws of physics. When a star collapses on this map, it tunnels inward, creating a new boundary, the event horizon. Look at the 45-degree light paths inside. Because space is tilted, even a beam of light can't angle wide enough to get out. It's trapped forever. Every path inside the horizon eventually crashes into this jagged red line at the top. This is the singularity. Look closely at how that singularity is drawn. It isn't a vertical wall in space, it is a horizontal line. Once you cross the horizon, the singularity isn't a place you fall toward, it is a moment in your future. There, time simply runs out. Penrose's diagrams show that while physics breaks down at the singularity, the event horizon acts like a shield, hiding that chaos from the universe. But this leads to a specific problem. What if a star collapsed, but failed to grow a horizon to hide its center? That naked singularity is the core of the cosmic censorship